Hi everyone, Dr. Gray here. Today we are working on Atmosphere and Weather Target 5, understanding how the composition of the atmosphere and its layers affect climate. So the atmosphere is the layers of gases that are held to a planet by gravity. And so gas has mass. If we think about a balloon, even a balloon or the gases inside a balloon have mass. Not a whole lot, but there is some mass. And because gases have mass, there's a gravitational attraction between those gases and the Earth's surface. And so it is gravity that keeps our atmosphere from floating off into space. Now, if we look at if we look closely at our atmosphere, we find that it is divided into layers, and the layers are divided based on temperature changes. And so if we move away from the surface of the Earth, we first find ourselves in the troposphere. And in the troposphere, we find all weather and all life. There is no weather and no life outside or beyond the troposphere. And in the troposphere, as you move away from the Earth's surface, the temperature decreases. Now, at the top of the troposphere, you encounter the tropopause, which is the dividing line, so to speak, between the troposphere and the stratosphere. The stratosphere, compared to the troposphere, is very dry. There is very little moisture. We also, in the stratosphere, this is the layer that contains the ozone layer. And ozone is a type of oxygen. It contains 3 oxygen atoms. And that ozone layer absorbs ultraviolet radiation from the sun and prevents it from hitting Earth's surface. And this is a really good thing. Without the ozone layer, there would not be life as we know it on this planet. Now, as we move away from the Earth, the temperature of the stratosphere actually begins to increase. So the temperature of the troposphere decreases, the temperature of the stratosphere increases, and it's because it's absorbing that ultraviolet radiation. It's absorbing radiation, that energy has to go somewhere, and so it's converted to heat. And so the stratosphere actually increases in temperature. The next layer above the stratosphere is the mesosphere. The mesosphere is the coldest layer of the atmosphere. So in this layer, from the bottom of the mesosphere to the top of the mesosphere, the temperature gets continually colder. And the reason for this is now there is so little gas particles in this layer to even create or to even have to rub against each other to have any temperature. This is also the layer of the atmosphere where meteorites burn up. So if you see shooting stars or you're going out to watch a meteor shower, what you are watching for are those asteroids, those space rocks falling towards Earth and getting burned up in the mesosphere. They get burned up because now the density of gases is great enough in the mesosphere that as that falling rock brushes or rubs against those gas particles, the friction causes that rock to heat up to a very high temperature, then it ultimately breaks that meteorite or breaks that asteroid apart, creating the meteor shower. Above the mesosphere is the thermosphere. This is the layer where satellites and the shuttle orbit. This is also the layer where the northern lights or the southern lights are observed. We live in the northern hemisphere, and once in a while here in Maine we get lucky enough to see the aurora borealis. If we lived in the southern hemisphere, the very southernmost portion of Australia, we would be able to see the aurora australis, or the southern lights. And those would also occur in the thermosphere. Above the thermosphere or beyond the thermosphere is the exosphere, and the exosphere extends 64,000 kilometers above the surface of the atmosphere, which is a really, really long distance away. And most people actually think of the atmosphere ending or space beginning well before that 64,000 kilometer mark. Here at the bottom, I have a mnemonic device to help you remember how to remember the order of those layers. For a mnemonic device uses the first letter in each of those terms and then makes a silly sentence out of it. So the letters we are using are T, S, M, T, E. And so one mnemonic device is turds stink, my turds especially. Sorry if that's too crude. You could always use that stupid metronome ticks endlessly, or that silly metronome ticks endlessly. You could make up your own mnemonic device, or you are free to use mine. So I mentioned earlier that Most pilots, I guess I should say, consider the Kármán line to actually be the edge of the atmosphere. And that is found 100 kilometers above Earth's surface. Now, the reason that's considered the edge of the atmosphere by pilots is because above 100 kilometers, there's not enough air to support the flight of planes. In other words, if you tried to put an airplane, if you tried to fly an airplane at 110 kilometers, it wouldn't stay in the sky. It would fall out of the air because airplanes require air to create the lift that pulls them up into the atmosphere. If there's no air, there's no lift. If there's no lift, there's no flying plane. And that height is at 100 kilometers, even though the atmosphere technically continues up to the 64,000 kilometer mark. Now, what is the atmosphere made of? We are interested in knowing the composition of the gases in the atmosphere. And by composition, we're looking for a description of what and how much. What are the gases in the atmosphere, and how much of the atmosphere do each of those gases represent? And so the primary gases that make up the atmosphere are nitrogen and oxygen. 78% of the air you breathe is nitrogen gas. 21% of the air you breathe is oxygen gas. The remaining 1% are trace gases. These include water vapor, argon, carbon dioxide, neon, helium, methane, krypton, and hydrogen. And the ones that are underlined, the water vapor, the carbon dioxide, and the methane, those are our greenhouse gases. Now, if we look at the atmosphere a little more, what's interesting to note is that most of the gases in the atmosphere are in the troposphere. The troposphere contains 75 to 80% of all of the gas in the atmosphere. The remaining 20 to 25% is found in the stratosphere up to the Kármán line. The remaining fraction of a percent is found above the Kármán line. Remember, the air above the Kármán line is so thin that it doesn't support, or the air doesn't support airplane flight. And so there's very little air. So the vast majority, 99% or above 99% of all of the air in the atmosphere is found below that Kármán line. So let's look at those greenhouse gases. The three greenhouse gases that you'll be wanting to know are water vapor, which is H2O, carbon dioxide, which is CO2, and methane, which is CH4. 75% of Earth's surface is covered by water, and so water vapor makes up a very large proportion of those trace gases in the atmosphere. 60% of those trace gases are water vapor. And so water vapor is the predominant greenhouse gas. It is the greenhouse gas that human activity does not affect. And what's important to note is that the amount of water vapor in the atmosphere varies from day to day and place to place. If you live near the coast or near the ocean, there's a lot of water vapor in the air around you. If you live in the desert, there's very little water vapor in the space or in the atmosphere that surrounds you. Oftentimes, water vapor is a gas that is a greenhouse gas that we don't give much credit to because it's not a political buzzword. There's nothing that we can do to change the amount of water vapor, either make it more or make it less, and so it gets left out of that discussion. The greenhouse gas that gets the majority of the conversation is carbon dioxide. Carbon dioxide is formed during the combustion of trees and fossil fuels. The carbon dioxide that is formed by combustion or burning of trees and fossil fuels can be removed from the atmosphere by plants or other light-dependent organisms that use photosynthesis, and they turn that carbon dioxide along with water vapor into fuel for that plant. Carbon dioxide is also absorbed by the oceans. The third greenhouse gas is methane, And methane doesn't get a lot of press, though it should, because it is a much more dangerous greenhouse gas. It traps a lot more of Earth's heat than carbon dioxide. Methane is formed during the decomposition of organic matter underwater in the absence of air. And so when plants decompose in marshes, the rotting matter in the underwater in rice fields, those both produce methane. Livestock, cows, sheep, produce a huge amount of methane. Landfills are responsible for a lot of methane production because in that case, just like with the earlier case, we have the organic matter that's decomposing in the absence of oxygen. Methane is released when we mine for coal and crude oil and when we mine for minerals. There are other greenhouse gases that we won't go into. Some of those are ozone. If it's produced in the troposphere, it's a greenhouse gas. Nitrogen oxides, as well as chlorofluorocarbons, or CFCs. Those are also greenhouse gases as well. Now, since we're looking at how the composition of the atmosphere and its layers affect climate, we probably ought to consider some of the other things that affect the long-term weather of an area as well. The first one, and probably the most important one, is the latitude at which a location is found. We live in Maine. We're up here firmly in the temperate zone, which means we don't get nearly as much solar radiation as they do in the tropics. The tropics receive the most solar radiation. The climate in this region of the planet is generally hot year-round. Often it is very humid as well. Notice how much water there is located in the tropical region. And so when the solar radiation is absorbed by the ocean at that location, a lot of water evaporates, increasing the humidity in that area. The next zone is known as the temperate zone. Temperate. And there are two temperate zones. There is the northern temperate zone, and this is where Maine is. And there is also the southern temperate zone. In both of those zones, there are typical four-season weather. There are cold winters, warm summers, mild falls and springs. And then lastly, at the poles, we have the, of course, polar zone. There is the northern polar zone, and there is the southern polar zone. And the polar zones have long, cold winters, short, cool summers with long hours of sunlight. And so, to summarize the effects of latitude, the greater the latitude, whether you're north or south of the equator, the less solar radiation that reaches the surface. As a result, the cooler the temperatures there. The next factor, which has an important influence on climate, is the presence of large bodies of water nearby, whether they are oceans or Great Lakes or large rivers. Large bodies of water have an important influence on climate, and that is water heats up and cools down more slowly than land. And so coastal areas, that is, areas that are close to those large bodies of water, have cooler summers than areas that are not next to large bodies of water. They have warmer winters than areas that are not next to large bodies of water. In addition, ocean currents affect the temperatures of those large bodies of water. And so the Gulf Stream is an ocean current that carries warm water from the equator up towards the North Pole on the eastern side of the United States. Well, that Gulf Stream carries warm water all the way to the west coast of Europe. And so even though Europe is at a higher latitude than most of America, Europe is as warm as most of America. On the west coast of the United States, there is an ocean current that carries cold water from the North Pole towards the equator, down the coast of Washington and Oregon and California. And that cool ocean current keeps the coast much cooler along that side of the continent. Well, because the water is cooler and less water evaporates because it stays cooler, the west coast of the United States tends to have drier, less humid air than the east coast of the United States. And lastly, of course, since coastal areas have more moisture in the atmosphere, there's more precipitation in those coastal areas than there are in areas that are located inland, farther away from those large bodies of water. The next factor that has an important influence on climate is the presence of mountains. So there's a couple of different things that are going on here. If you are at a low altitude, then the temperatures are warmer. If you are at a high altitude, if you live on the top of the mountain, the temperatures are cooler. And that's because there is less land at the top of that mountain to absorb the sun's radiation and radiate it back out into the atmosphere. Whereas when you're at the bottom of the mountain, you're close to the rest of the surface of the earth, and so there's a lot more mass to absorb the sun's heat. And so that's one piece of the effect of mountains. The other effect, or the other part of the mountains conversation, has to do with what happens when winds blow across mountains. And so for every mountain, there is a windward side. That is the side of the mountain that the winds blow onto or blow into. Well, if we think about this wind, if this is warm, moist wind, for instance, or warm, moist air, for instance, as it gets closer and closer to that mountain, it's going to get pushed up over the top of that mountain. And as it goes up over the top of that mountain, it's going to get cooled down. And that's going to cause the rain or the precipitation to fall on that windward side. Whereas by the time that air makes it over to the leeward side of the mountain, the side of the mountain that the wind doesn't blow onto, well, that air has been dried out. All of the water has essentially been squeezed out of it. And so the leeward side of the mountain is dry, much drier than the windward side. If we think about the Rocky Mountains, for instance, the western slopes, the western side of the Rocky Mountains, well, that's the windward side. The western slopes of the Rocky Mountains is where most of the food production happens. The eastern side of the Rocky Mountains are dry. They are almost desert-like on that side. Very little rain falls on the eastern side of the Rocky Mountains because all of that precipitation condenses as that warm, moist air moves up over the top of that mountain peak. Now, the last factor that has an important influence on climate is the presence of large cities. So, large cities contain lots of concrete, a lot of skyscrapers, a lot of buildings, and that rock and concrete and asphalt absorbs that solar radiation all day long. At night, when the sun goes down, those buildings now radiate that heat back out into the atmosphere. And so cities, on average, are several degrees hotter than the corresponding countrysides outside those major metropolises. In the countryside, that solar radiation is being used by plants to perform photosynthesis, to make food for that plant. And so that energy is not being converted to heat, it's being converted into sugars, essentially. And so, since it's not being converted into heat, those rural areas, those tree-heavy areas, are cooler than the city a few miles away might be with all of its concrete. So now we've looked at climate. Climate is the typical weather in an area. It is the normal, expected wintertime highs and lows, summertime highs and lows, typical precipitation, typical wind direction and speed. Climate is the long-term weather of an area. Weather is simply a description of what's going on right now. Right? We have this saying in Maine, if you don't like the weather, wait 5 minutes. It's going to change, or it could change. Weather is very variable. It changes minute to minute, day to day, week to week. So if you're watching the news and you're waiting for the weather report, You are waiting for the meteorologist to come on and tell you what the likely atmospheric conditions are going to be in the next day or the next hour or, excuse me, next week. He's not telling you what the climate is going to be like because the climate patterns have already been established. And so when that weather forecaster comes on, think about what are the things that he describes. He describes how many days of sunshine there might have been, what the atmospheric pressure is, and whether it is rising or falling. We're always interested in what's the likelihood that it's going to rain or snow or there's going to be some sort of precipitation. What the temperature highs and lows are going to be for that day or the next coming week. What the relative humidity is going to be. Is it going to be a hot and humid sticky day or is it going to be a dry breezy day? And the wind's speed and direction. Is it going to be a breezy day? Is it going to be a still day? Is it going to be very windy? These are the characteristics that we would describe if we wanted to describe the current state of the atmosphere. Now you're going to have to know these, and so let's look at an easy way to remember them. We've got a list of 6 things here. Whenever we have a list, I like to come up with a mnemonic device. And so the mnemonic device I'm looking at today, we're going to use the first letter of each of these terms. We have Darth W. Well, Darth Waiter. Not Darth Vader, but Darth Waiter is the way I remember those atmospheric conditions. That's it for today. I'll see you in class.